Alright, so we're going to do this video on triangle centers. The first one we're going to do is the circumcenter, and this is formed by perpendicular bisectors. So we're going to have a bisector, which cuts our side in half, and it's going to be perpendicular, so it's going to create a right angle. So that's going to be about right here. These are just going to be like kind of rough sketches. Um, we have another one right here. Let's say that's about 90 degrees shoreline. And here, which is going to be 90 degrees as well. Okay, so I'm going to go ahead and create my center here. So this would be my circumcenter about right here. And I'm going to redraw my lines after that. So from each point, I have this one here, and then this one here. And again, we're going to say that each one of these is going to be perpendicular. And then so the thing with circumcenters is that from each one of our vertices of this triangle to the circumcenter, they are going to be equally distanced. So here to here, here to here, and then here to here. So let's say if I called this triangle A, B, C, and this is point D. The length of AD is going to be equal to the length of BD, which is also going to be equal to the length of CD. Okay? So this is for circumcenter. So if I wanted to say, maybe I wanted to figure out, let's say I knew what AD was, it was like 2x plus 3. I know that BD is 9. I just set those two equal to each other. I solve for x. That's how I'd find x for that one. All right. So again, that's for circumcenter. For our next one, we are going to do incenter. Incenter, that's created by angle bisectors. So again, I am just going to roughly sketch. We're going to cut each one of our angles in half here. That is a terrible one, but let's try to make that look a little bit better. Sure. We'll say that's about the same too, and we'll do this. All right. So this would be our incenter right here. Again, that's created by angle bisectors. Angle bisectors cut my angle into two equal parts. Again, I'm going to erase these and then redraw my lines here. So from here to here, from here to here, and then from here to here. All right. This incenter is going to create sides that are equal from our side of our triangle to our incenter. Now again, this is not the most drawn to scale picture here, but for an incenter, this side would be just equal to this side, would be equal to this side right here. So those three would be equal to each other. Again, as I said, not drawn well. I know this one doesn't look like these two, but they should all be equal to each other, okay? So that is circumcenter, and we've also done incenter. The next one we're going to do is centroid. So let's erase these. Centroid goes from centroids are created by medians, and medians go from one of our vertices. So let's say from C to our midpoint of its opposite side. So let's say right here. For B, it'd go from here to here. And then for A, it would go from here to here. This is probably the best one so far. But this would be our centroid. I don't actually have to erase anything here either, okay? So I would just go ahead and have this right here as my centroid. Now, centroids are probably the most confusing ones with terms of knowing about the side lengths. So let's say, I'll say this is y right here. and then we'll say this is D again. So A to D is equal to 2/3 of AY. So our long side will be equal to 2/3 of our whole entire median right here. And then from our short side, which is dy, that's going to equal 1/3 of our whole entire median. So it's equal to 1/3 of AY. All right. And so if that's 2/3 and that's 1/3, that means that AD is going to be equal to twice the length of dy, so 2 dy. And conversely, dy is going to equal 1/2 of AD. Again, this is for a centroid. Again, and this is the probably most confusing one of all of them. But we have this here. All right. And then lastly, we have orthocenter. Orthocenter, that is created by altitudes. And altitudes go from our vertex to our side. That creates a perpendicular line. So let's say, again, we're going to have to eyeball these ones because I don't have anything that's going to give me a proper right angle here. From here to, let's say, this looks like about a right angle to our opposite side. That's going to be one of our altitudes. We'll say that this will be an altitude here. And then we'll say that, well, it should be roughly around there. But this would be our third altitude. So this right here would be our orthocenter. And again, created by perpendicular lines from our vertex to one of our sides. All right. And there's no special side congruence to it to remember for that one, but we just need to know that it's created by altitudes. So that's circumcenter, incenter, centroids, and orthocenters there.